Alright, so we're talking trends today. There's 2 trends you need to know, and there's actually 4 in your book. So when you get to section 6.3, there's 2 you can ignore, so you just need to know these 2. First of all, we want to know the cause of the trend. Okay? So as we go across, remember this is called a period, and going up and down, that's what we call a group. Okay, the cause of the trend, well, if we consider as we go across what happens, we add protons. So we can say our cause is our nucleus is getting stronger as we go across. And that's true for any period. Now when we're talking the number of shells in a level, the shells stay the same. So this has 1 shell, that has 1 shell. As we go down vertically, the cause of our trends is that we're adding shells. So if this is level 1, this is level 7, we would have 7 shells. Okay, so our cause going vertically, more shells. Alright, now the result of that. Well, there's 2 trends we need to know. One is for size. Now when we're talking size, what are we talking? We're not talking about the nucleus, we're really talking about electrons, because we know that most of an atom is made out of electrons. The nucleus is on the inside and it's way small, so that's not really going to change. Even if the nucleus doubles in size. We said that this is like a marble in a football stadium. So if we double the size of our marble in a football stadium, it's not really going to affect the size of the football stadium. But what will happen is that the nucleus attracts the electrons. Okay, so I have a weak attraction here for this electron. I have a big attraction for this electron. So what's going to happen is this atom, this nucleus is going to pull that electron closer to it and make that atom smaller. Okay, so the size, my trend is, as I go across, my size gets smaller, it decreases. Stronger nucleus pulls everything closer together. You can think of it too like a solar system. If I have a sun here and a bigger sun here, okay, the smaller sun, it's not going to pull on those planets very much, but a great big giant sun is going to pull in everything closer to it. Alright, now going down, we said the cause of the trend is adding shells. So here I have 1 shell, here I have 7 shells. The nucleus does get bigger, but it's way in the middle. It doesn't matter, so all that matters is the shells. So obviously 7 shells, the size as we go down, the trend is it's going to increase. Alright, and the second trend we need to know is called electronegativity. And essentially what this is the strength of an atom, or the pull that it has on an electron. Alright, so if I'm given, let's look at the trend going across. Again, if I have this atom with a small nucleus, and this atom with a bigger nucleus, which one's going to have the bigger pull on the electron? Well, the bigger the nucleus, the stronger the atom. So we'd say this one has a greater electronegativity or a greater strength. So our electronegativity increases as we go across. Bigger nucleus, stronger pull, stronger atom. As we go down, well, you might think stronger nucleus, stronger pull. However, we're looking at, let's say we have these 2 atoms, and an electron comes floating by. We want to figure out who's going to pull that electron more, this one or this one. Well, even though this has a bigger nucleus, it's surrounded by electrons. This is cesium, element number 55. It's got 55 electrons. So even though this is strong in here with its positive charge, this electron comes by, well, this is not going to feel it, right? Even though this is positive in here, it's blocked by all of these other electrons, and it's far, far away. Whereas this atom here, even though it has a smaller nucleus, there's no electron blocking it. Okay, so we say this one is stronger. This one has a higher electronegativity than this one. So our trend, our electronegativity decreases as we go down. And going back to the solar system analogy, if I have a sun with one planet here and a sun here surrounded by 55 planets, when that other thing comes floating by, this one's going to attract it much more because it's not covered up. Alright? It's like this is one direction in here. It's very attractive. They're very attractive, so I've heard. Surrounded by all of these girls. This is you. You might be somewhat attractive, but you're not surrounded by 55 girls. So when this girl comes walking by, there's going to be more attraction here than there is from here. Alright, now with electronegativity, you got to know who's the strongest. The strongest of all atoms. Let me give you some choices. Let's say we got lithium. We got cesium. We've got fluorine. Those are the three corners of the periodic table. Alright, I guess we could do four corners. Iodine. So looking at the trends we just did for electronegativity. We said it gets stronger going this way. It gets weaker going this way. So based on those trends, who's the strongest atom? Fluorine, right? Because we get stronger going across this way, so that means fluorine is stronger than lithium. And we get weaker going this way, so that means cesium is weaker than this, and iodine is weaker than that. It gets weaker. So that means the strongest atom of all is fluorine. So if these guys get into a competition, a tug of war, this guy's going to win. What about neon? How come neon is not stronger than fluorine? And it's a noble gas, right? And noble gases don't pull. They don't have any attractions. They're happy. We'll talk more about that in the next chapter. Since he's a noble gas, he doesn't want any electrons. This electron comes floating by. He's indifferent. He's happy. He's stable. He just doesn't care. But fluorine is the strongest, so he's going to pull that electron in and keep it for himself. Anybody else comes and tries to take it from him, they're going to have a hard time because fluorine is strongest. Alright, now on your test, we'll have something like this. We'll give you, let's see, we'll say, who has the higher electronegativity? And you'll get two options. So let's go with oxygen and fluorine. Oxygen being number 8, fluorine being number 9. So which one's stronger? Fluorine, of course, right? Because we just know the trend. The trend says it gets stronger going that way, so therefore it's fluorine. Then we might get something like, it might say, which one has the greater electronegativity, lithium or sodium? Who's stronger? Lithium. Because our electronegativity decreases as we go down, so therefore he's stronger. Alright, we'll do the same thing with size. Going back to size, if I have oxygen and I have fluorine, which one is larger? This is the one people always get confused on. Our trend, we get smaller as we go across because this has 9 protons pulling the electrons closer together. This one has 8 electrons, so the electrons are 8 protons, so the electrons are a little farther away. And so fluorine is going to be smaller, so oxygen would be the larger. And if we talk about something like lithium and cesium, which one's bigger? This is in level 2, right? So it has 2 shells. This is in level 7, or 6 rather. Is it 6 or 7? 6. So it has 6 shells. 1, 2, 3, 4, 5, 6. Okay, so cesium is going to be a lot bigger. Even though, well, not even though, a lot more shells, a lot more layers, less layers. So cesium is going to be larger. Alright, so we'll do some practice with those for the next few days. But those are the 2 trends. And remember, ultimately, learn the cause of the trends, because if you just try and memorize them, people always confuse them.